Once again, welcome. Now let us solve the problem of cantilever from the fixed end. This is the UDL of 1 kilonewton per meter, and at the end C there is a load of 4 kilonewton, and this fixed beam, the end is suppose A, and here we are giving the point B here. Okay, this is the 4 meter span, 2 meter span in between B and C. So the problem statement is what? Draw SFD and BMD by calculating their values. So this problem already we have done. You can refer my video in the comment box. So what else, what new we are going to do here? So here we are going to start our calculation from the fixed end. Calculation from the fixed end means from A. Okay. As we know, generally it is preferred to start our calculation from the free end in the case of cantilever. But suppose we want to know what means how it may be more expensive in terms of calculation if we start calculation from the fixed end. So let us do it. Okay. So firstly, what we have to do, we have to get the support reaction. To get support reactions, what we have to do, we have to draw SFD, the free body diagram of the beam. Okay, this given beam is the load, we can say the load diagram. Now in free body diagram, so what we are going to do, we are going to remove the supports. So here it is RA, or we can say the VA, HA, and the load will be there. तो हमें क्या करना है, जब भी FBD बनाएंगे सपोर्ट रिएक्शंस को हटा के उसके बदले में जो भी रिएक्शंस हैं वो शो करने हैं. Okay, so this is of 1 kilonewton per meter, and at the joint C it is 4 kilonewton, and this is of 4 meter, it is of 2 meter. Okay, and C at the end A, the fixed joint, you can say how many reactions? 3 reactions. So HA will be 0 because no horizontal forces, means external forces are there. Okay, and what about the resisting moment? ठीक है, ये आप कह सकते हैं moment at the end A due to the support. So MSA better to write as MSA. Okay, so in this way we have done the free body sketching diagram we have drawn. Okay, so what is next now? Next is you have to find out the support reactions. तो देखिए यही डिफरेंस है. अगर हम फ्री एंड से स्टार्ट करें तो सपोर्ट रिएक्शंस की कोई ज़रूरत नहीं है, नो नीड टू फाइंड आउट द सपोर्ट रिएक्शंस. बट अगर फिक्स्ड एंड से करें, क्योंकि स्टार्ट वहीं से करना है, तो अननोन वैल्यूज फाइंड आउट करने होंगे, एंड लेट अस फाइंड आउट द अननोन वैल्यूज. तो कैसे करेंगे? वी हैव टू सेटिस्फाई द इक्विलिब्रियम कंडीशंस. सो समेशन ऑफ Fy इज इक्वल टू 0. एक्स डायरेक्शन करने की जरूरत नहीं है, क्योंकि एक्स डायरेक्शन में ऑल द फोर्सेस आर 0. That's why the reaction is also 0. Okay, so by this we will get और यहाँ पे क्या करना है, वन थिंग, हमें नो नीड टू फॉलो द साइन कन्वेंशन ऑफ SFD BMD फॉर द कैलकुलेशन ऑफ सपोर्ट रिएक्शंस। तो जो पहले कहते थे साइन कन्वेंशन के अकॉर्डिंग, जो इक्विलिब्रियम कंडीशन कंसिडर करके अननोन्स फाइंड आउट करते थे, तो उसके लिए जो साइन कन्वेंशन जो यूज करते थे, तो अपवर्ड डायरेक्शन के लिए वी यूज व्हाट, पॉजिटिव, ठीक है। so that's why VA with positive. And then what about this? So 1, and then the 4, the length span of the UD, then minus 4, which is working, the point load working, and C, and what about this 1 multiplied by 4, that is equal to Wx, and W is what, the load intensity, and X is here what, that is the length between A and B. So is equal to 0, and what we get then, VA is equal to 8. Similarly, summation of MA is equal to 0, then the support reaction in terms of moment, MSA then minus, that is what, 1 multiplied by 4, then 4 by 2. This is where the UDL is acting. So it is acting at 4 by 2 minus 4 into 4 plus 2. So what we get is equal to 0. Then we get, this is 8, and 4 into 6 is equal to 0. So we get MSA is equal to 32. Okay, what is this MSA once again? So support, the S means the moment, you can say the resisting moment at support A. Okay, so in this way we have calculated, we have found out the support reactions. Now next what we have to do, we have to start our calculation for the shear force and the bending moment. So for the shear force calculation, then we have to opt the sign convention. And what is the sign convention? So suppose this is a beam A, B, and we cut it, imaginary cut, XX, and from XX the end A is X distance, suppose, and reactions at the ends. So this is RA, RB, and RA. So left side, we're talking about left side. Okay, so these are upward direction, we take positive, and the left side downward we take a negative, right side downward we take positive, right side upward then we take negative. This is the sign convention for the SFD. Sign convention for the SFD. So now so shear force we can calculate let's denote shear force by F, and we want at FA, shear force at FA. So that is equal to, this is the VA, and as per the sign convention, this we are following, so positive. That's why is equal to 8 kilo Newton. What about at B, shear force at B? So it is now VA minus WX, and VA, that is 8, W here 1 kilonewton per meter, and X is what, the length in between AB, that is 4. So E is equal to what we get, the 4 kilo Newton. Okay, and what about at C? So you can see here, in between B and C there is a no load is acting, no force is acting in between. Not ये फोर्स को कंसिडर नहीं करना है, ये जस्ट सी की जस्ट पहले. So B to C means it remains constant. So FC is equal to FB. The shear force remains constant, and that is equal to 4 kilo Newton. Okay. And what about the bending moment calculation? Bending moment calculation. So let us denote it by MA here, the bending moment at A. So MA, that is equal to minus MSA. As per the sign convention, this we take negative. Beam is here, beam, and the imaginary cut is here. So left side, right side both. The left side, the anti-clockwise, we take positive. Right side, the clockwise, we take positive. So following the sign convention, what we get here, the bending moment at A, that is minus 32. And what about at B? Bending moment at B. So what we have to consider, this support reaction moment we have to consider. Then also we have to consider the support reaction, and the direction is C. You can see like this. R means VA contributing like this, means we take it positive. So that's why here VA then multiplied by 4 meter from the B. So what we get then, it is 32 plus VA is equal to 8 multiplied by here 4. So, and one more thing, here we have to consider the with minus sign WX, means W is what, 1, and 4x and 4 by 2. So what we get here, that is the 8. So we get here minus 8 kilonewton meter. Here so kilonewton meter. Okay. And what about at C? So MC is equal to what? Minus MSA, and then plus VA, and then now multiplied by the distance 4 plus 2, and then WX, W means 1, X now, that is the length of the UDL 4, and now the distance from the point C. The distance from the point C from here, so here, this distance we want. So it is 2 plus 2. So 4 by 2 plus 2. Then what we get here, this is equal to minus 32, and 8 multiplied by 6, and minus here 1 multiplied by 4, then multiplied by here 4. So it is minus 32 plus 48 and minus 16. So we get 0. So it is correct because there is no support at the end C. So that's why the resisting moment will be 0. So in this way we have calculated the shear force and the bending moment. So we have not considered in the equation the variables like if we cut the section, then we take variable like from the section it is x distance. So that is not included in this. That I will include the section method, that is known as the section method in the next video. So what about the bending moment diagram, and before that shear force. So obviously based on the data, based on the calculation, let us do here the shear force SFD. So just below the load diagram you have to do it, and it is A, it is C, it is B. So we get here 4 kilonewton, and sorry, it varies because there is a UD load. So it varies like this, and then it becomes constant here, and it is of 4 kilonewton, and the end A, the magnitude of shear force, it is 8 kilonewton. Similarly for the bending moment, so we can draw here BMD. It is A, B, then C, and here what we got, the magnitude, that is minus 32. This is minus 32. And what about at B? So at B it is minus 8. So 8 here. Okay. And how it varies? So it varies. What kind of equation we get in between for the UDL? So we get the parabolic. So that's why it is parabolic. Okay. And what about B and C? So at C it is 0, and B and C there is a only point load, so linear equation we get. So in this way we have done SFD and BMD. In the next lecture I will calculate it through the section method, in which we will consider the x variable in the equation of shear force and bending moment if UDL, for the UDL portion. So with this, thank you.